Friends, today I am now going to discuss how to derive phase angle, that is phase angle in case of op amp. Yeah, it's a continuation to our previous electronic series. After this video, in my next video I will continue the classical lectures also, classical series also. So let's start discussion how to derive or how to deduct phase angle you can say in case of op amp. So let's start by an example. Let's start. So first of all, I'm drawing an op amp. So you can see this is an op amp. So here in this case we will derive what is a phase angle with the output voltage with input voltage in case of op amp. So here 1 kilo ohm resistance is there. If here I1 current is flowing, let us consider here I1 current is flowing. I'm drawing properly, erasing it. So you can see here 1 farad capacitor is there, and here 1 ohm, here 1 kilo ohm, and here 1 ohm resistance is there. So how we will proceed in this case? So let's start step by step. Step by step means in this point and in this point, in this between these 2 points, let us consider here in this point the potential of this point is as Vx, and here let us consider I1 current is going here and here I2 current. Now you can see here first our task is along this circuit, within this circuit you can see RC is there, here resistance, here capacitance. So our first task is what? Our first task is here we have to convert farad into ohm. That means if we convert farad into ohm, and then we can discuss, then we can easily derive that portion. We can easily derive this Vx. That means the voltage of here is equal to, I'm showing you by different color pen. You can see voltage at this point and voltage at this point, they are same. I have discussed in my previous video that they are same by virtual ground. In my previous video I have discussed virtual ground concept also, that voltage in this portion, in this point, and voltage in this point, they are same. So our first task is to derive Vx. So step 1 is to derive Vx, means voltage at this portion. So to derive Vx, first our task is what? Here capacitor is connected. Here capacitor is connected in this region. Here R and here capacitor. Capacitor's unit is what? Capacitor unit is farad. So our first task is what? Our first task is to convert farad to ohm. So if now I'm writing in another page, if you are given R and C, so how you will convert that capacitor into resistance? Now let's change the pen color. So 1 by j omega c, 1 by j omega c is used to convert farad into ohm. Means let me write properly. My handwriting is not so good. Please don't mind. Please cooperate with me. 1 by j omega, let me write clearly, means if capacitance is given to you 1 by j omega c, it is used to convert, if capacitor unit is farad, to ohm. If you are given L and means inductance and resistance, that is j omega L, you know, only j omega L, that is used to convert L inductance into ohm. But here capacitance is given, so 1 by j omega c is used to convert inductance into ohm. Now capacitance is what here? 1 farad, and omega is also 1. We are assuming here omega is also 1. So now I am drawing that portion, Vx portion. Here that op amp is there, op amp was there, and here R is there, here capacitance is there, see, and here 1 ohm. So what will be, and here this point is Vx, So Vx, let me write clearly, very much bad handwriting. So in this point it is Vx. So how we will compute Vx? So the rule to calculate the Vx is, first you have to know the input voltage. Here input voltage is what? Here AC is sin t voltage is given. Sin t signal is given. So our rule is that here input voltage sin t into the opposite portion resistance. Here it will be what? If we convert this capacitance into ohm, then it will be 1 by j omega c, and c is 1. Omega equals 1 and c is 1. We have taken omega equals 1 and c is 1. So this input voltage and into this opposite side resistance, here it will be what? 1 by j omega c divided by this resistance plus this capacitance. I'm again telling, if here input voltage V in is given, how to compute this Vx here? If here V in is given to you, so V in into this opposite side capacitance or resistance, whatever, when you will convert capacitance into resistance, divided by this R plus 1 by j omega c. Now omega equals 1 and c equals 1 you have taken. So now our task will be that to compute Vx. So Vx equals, that input voltage was what? Sin t into 1 by j omega c. Omega equals 1 and c equals 1 we have taken. Capacitance 1 farad you know, and omega equals 1 I have taken for calculation. 1 by j sin t into j omega c means 1 by omega equals 1, c equals 1, that is 1 by j, divided by r plus 1 by j omega c, that means 1 by j. Now here LCM, what you will get at last? So Vx you will get at last, that is Vx equals, you will get sin t divided by 1 plus j after total calculation. So our first step is done. Step 1 is done. We have done step 1. Now our second step. Second step is what? Second step is that we have to compute output voltage. Because why? Phase angle is between which? Output voltage and that Vx, na? That means here I am drawing again that cop amp. Here resistance, here capacitance, you know. Now here resistance, here again resistance, here it is grounded. So this point Vx we have calculated. So at this point also same voltage is there, Vx, here also Vx. So now let us consider here I1 current is flowing and here I2 current is flowing. Okay, so what is the rule to calculate here? Just use KCL. So I'm again here only this part, for making you understand. Here I1, here I2. So here this point we have, here Vx is there, Vx is at this point there, so same voltage. So here from here we can say I1 equals I2. So here in this case, at this point let us consider it is grounded. Grounded means what? At this point voltage is 0. That means 0, here Vx voltage, here Vx, and here V0 voltage. So I1 equals I2. If we apply, what we will get? So we will get I1 equals I2, I1 equals I2, that 0 minus Vx divided by how much resistance was there? 1 kilo ohm, equals Vx I2, that portion, minus V0, and divided by, there was also 1 kilo ohm at that feedback portion, 1 kilo ohm. So from here what we will get? We will get Vx equals 2v0. Vx equals 2v0. So we will get what? Vx equals 2v0, and Vx what we have got? Sorry, here not Vx equals 2v0, v0 equals 2vx. Little bit correction in my calculation. v0 equals 2vx. v0 equals 2vx. Yeah. So after correction, Vx we have got what? Vx we have got sin t by 1 plus z, 1 plus j. We have got already. J is what here? J is imaginary number. Imaginary. 1 by j omega c. J is what there? J is imaginary. So Vx we have got sin t by 1 plus j. Now, so V0 what we will do? So V0 equals 2 into Vx, that means 2 into sin t divided by 1 plus j. Now, if I take magnitude in case of, let me write. Now, if I take the magnitude of V0, you know that it is imaginary number. So 1 plus j what is that? 1 plus j is complex number. So complex number magnitude is what? If I take magnitude, V0 magnitude is 2 magnitude will be remain same, sin t has same magnitude, 1 plus 1 square, that j will be 1 plus 1 square, that is 1 plus 1 root 2, that means root 2 sin t. After taking the magnitude of complex number, root 2 sin t. Output voltage is root 2 sin t. So this is the magnitude of output voltage. Now if we take the phase angle of that output with respect to Vx, what we will get? The phase angle calculation. Now the main part. When you will take phase angle calculation, you have to take not the magnitude, directly that portion. Angle, it's not it is angle, it is the I have denoted it by angle sign, angle, phase angle, 2 sin t by 1 plus j. So the rule is very simple like logarithm. That means angle of 2 sin t plus 1 by j, phase angle. So like logarithm you will break. That means it is in multiplication form na. So like logarithm we will write in the plus form, angle of 2 and angle of sin t, and it is in divided form. So like logarithm we will write in the minus form. Same rule like logarithm, minus of 1 plus j. Now angle of 1 plus j, angle of sin t, angle of 2. Now 2 is what? 2 is real. So if it is real quantity, the angle, phase angle will be 0. Sin t real, phase angle will be 0. So angle will be due to what? Due to 1 plus j. So angle of 1 plus j, what will be that? Angle of 1 plus j, minus of 1 plus j. So in case of complex, what you have got? X plus iy is that thing. So angle will be tan inverse y by x. That we have been taught now. So here minus of tan inverse 1 by 1. So here the angle will be minus pi by 4. Minus pi by 4. So what will be the actual output? That means it is lagging by pi by 4 angle. So actual output will be V0 equals root 2 sin t minus pi by 4. So in this way we will calculate the output voltage of any op amp. We will calculate the phase angle of any op amp. Phase angle rules are same as logarithm. So thanks for watching patiently. Thank you. Bye.